I have, over quite a number of years, thought about this problem, starting back in college and actually 37 years ago working in Midtown at Citibank, figuring out, and right at the beginning of the shuttle program, could there be opportunities for a big bank like Citibank to finance some sort of commercial activity in space? And actually the answer back then was not right now. Then I worked at NASA and was one of the first people to look at utilization of the space station back in 1985. And the thing that came out of that was that NASA is an engineering organization, particularly in some of the centers like JSC, and operational. And they've come to the realization that it's very good for them to focus on that and start moving utilization out, slowly out of NASA and into the educational, NGO, and commercial sector. And that's really taken place over the last 8-9 years. Nanoracks was founded in 2009 when there was this short window of opportunity for a small company like Nanoracks to say to NASA, look, you're very close to finishing the space station. It was finished in about 2011. Let us help you commercialize it. And they gave us enough rope. They thought we'd hang ourselves with it. Instead, we've grown quite a bit. I joined in 2010 and am the Chief Commerce Officer, covering contracts, some strategy, some marketing, and things like that. So very happy to speak with you today, and very much appreciate all the organizers' support for this. Let me see how we get down to the next page. There we go. Everyone's talking about vision here. Yes, our vision is now commercial space stations. Actually, when we started, we were a little less sure of the direction we go, and I will get to that and how we have come to the idea that commercial space stations are the right thing for our customers. Our big emphasis, and whenever we have a question about what we should do, the answer is look at our customers, see what they need. And that has driven us from our origin in 2009 to what we're looking at today and all the things we've accomplished along the way. And the other thing we realize is space is not going to be done by one company, one nation alone, one continent. It's going to be a big system of lots of people doing various activities. Even now, on some of the NASA activities, looking at Deep Space Gateway and beginning to look at commercialization of LEO, NASA is putting out a great set of interoperability standards so that various groups can work on orbit with each other, much like they've done with the ISS, where you have a Russian section and a US, European, Japanese, and Canadian section that all hook together and pretty much work together most of the time. So to really focus on what we do want to democratize space and make it low cost and, as we said, follow our customers. We did that really at the start by thinking, okay, what standards are out there that we can build on to make access to the ISS for microgravity research easier? And we took the CubeSat standard, and that has been focused more on launching satellites and things, and we said, well, there are systems already built for some of that, but we want to focus on microgravity that we can do on the station. That way you don't have to have solar panels or comm systems or GNC. You can focus on your microgravity research. Our first products launched in 2010 on STS-131 were our Nanoracks frames, and they held what essentially looked like CubeSats, 1U, 2U, 3U, up to a 2x8U. And we provide power and data and a mission length, usually around 30 days. We can bring them up, and since it's the station, bring them back down on things like Dragon. When we started, we were actually flying on the shuttle and Soyuz. So we did get a number of vehicles. I'll talk about that a little bit later. The benefit to that was multiple fold. One, we sort of created a sandbox in the idea of the CubeSat size, so people knew how big they could build their payloads. And it also helped us, we say that really Nanoracks survives on paperwork. A good portion of our effort is doing the paperwork that allows you to get to the ISS. And having a standard type payload makes that work easier. And that's something, there are lots of barriers that are technical, but there are also barriers that are programmatic, like doing all the paperwork. And then there are barriers that are financial. So we are trying to break down all those barriers. And we've done that by standardization, by keeping ourselves very lean, and by focusing on what our customers need. And really, if you want to look at the evolution of where Nanoracks has gone, I've sort of talked about the first barrier we tried to overcome, or bottleneck we tried to overcome. Very complicated to get payloads to the ISS back in the early 2010s. It is now much simpler. We have to say, we also generated competition for ourselves. There are 3 or 4 other small companies who are providing very similar services, and I think even in Europe, ESA, with the help of other groups, have supported a group called IceCube, who's doing something very similar. So we feel like we've been very successful. It's created somewhat of a standard. People can move relatively easily between competitors, and it's also successful because we've done over 375 student experiments. Our nanolabs are, as I said, the size of CubeSats. To even lower the cost further, we developed something called mix sticks. It's really a Teflon or a polyethylene tube with a bunch of clamps, so you can do a mixing experiment in microgravity, and we can price those, below 20,000 for schools on an individual basis. And we have programs like SSEP with the National Center for Earth and Space Science Education. I think you'll hear from Jeff Goldstein tomorrow on that, or at least part of that. And so it's been a very successful program in reaching out and making space available. I sort of compared to what would be the cost of a musical for a school, sort of following Erica's football uniform example. And you can do a space experiment with a curriculum already provided, or most of the curriculum already provided. As the shuttle came to the end, there was concerns about infrequent access to the ISS. We overcome barriers sometimes with what we do inside Nanoracks, but we also take advantage of things that are happening outside. The CRS contract, that's commercial resupply for the station, has been a really incredible success for using the station because it has provided frequent access and access up and down with a fairly large amount of down mass. That was an innovation that SpaceX was able to provide, and that has made continuing research much better, and we've been able to take advantage of the frequency of flights to allow customers who don't quite make the deadline for turning over their hardware for a flight to slip to the next flight. And that we find happens quite often. And the other thing about both the frequency and the lower cost is we now say, it used to be failure is not an option. Now, as long as you fail safely, it's okay to fail. We've had people who've flown multiple times, and they failed, but they learned each time. And that is probably more important to science than having a success the first time you try an experiment, because that probably means you knew the result already. And so we've done that. While it's great to have things coming back from space, some people want to get the results back right away. And we started back in 2011 with a plate reader. It's a piece of equipment, it's a photospectrometer focused on microplates, which are common in every lab, to do the beginnings of in situ analysis of microbiology activities. And we are actually now in the second generation of that. NASA and CASIS, the Center for the Center for Advancement of Science and Space, have supported a number of other analysis tools up there. And that's something where bringing the scope of research that you can do, not just the exposure to the environment, but analyzing what happens in that environment, has been a great breakthrough and continuing. We're working on other bottlenecks that we're trying to overcome. We have some great ideas about how we're going to do that, but we're holding those close to our vest. But as we look forward, and given the title of today's symposium, we do see the ISS eventually being a bottleneck for either capacity, or the ISS is a compromise in terms of microgravity, power, even programmatic activities. You have astronauts and cosmonauts on there. There are certain things you can't do safely. So having, say, an independent space station that is either crew-tended or just autonomous means you can go and use highly toxic materials and not have the safety constraints you have on the ISS. And again, this is sort of standardized hardware, ranging from nanolabs to CubeSats. One thing I didn't talk about is actually one of the biggest parts of our business now is launching CubeSats off the ISS. It's been a mix of university and tech demo for commercial companies. We're finding that that is an ever-evolving business, and we've done that and continue to do that off the ISS. We now launch off the Cygnus vehicle, one of the other supply vehicles to the ISS, which takes us to a higher orbit. And the regularity there is very important for some of our customers, and the ability to shift from one launch to the next if you don't quite make your schedule. And again, as I said, it's an ecosystem. We've relied on a number of launch vehicles, both from the US, SpaceX, and Orbital. I guess it's now Northrop Grumman Orbital ATK. Is that a long enough name? And we've ridden up on the Russian Progress. We've actually ridden down on the Soyuz. We've had all sorts of payloads on the HTV, and we're looking forward under the next commercial resupply contract. There'll be 3 US companies supplying the station. SpaceX, Orbital, and Sierra Nevada will have something called Dream Chaser, which is a sort of mini unmanned shuttle that will be supplying the station and bringing cargo back down. And the nice thing about the ride back down is it'll be a little softer than a ballistic descent, which is what SpaceX does. And again, our Nanoracks ecosystem has grown from the space station. We're talking to other expendable launch vehicle providers for CubeSats. We do work with Blue Origin, and we're very excited about that. We're talking to a number of people about how we can take our services and provide them on vehicles that are going to the moon or around the moon. And also, sort of as a build I'll talk about a little bit later, we're actually putting our own airlock on the space station. It will be sort of a module that allows larger items to get moved from inside to outside the station and back. And then up at the top right, I'll talk a little bit more about our Outpost program, and that is the logical conclusion to saying what bottlenecks do we need to overcome. And of course, we will always follow our customers. This is actually a slide now that's probably 4 or 5 years old, but we've had a great array of customers, from national space agencies to commercial companies like Planet and Spire, to educational groups like National Center for Earth and Space Science Education. And it's great to have this broad array of customers because they present us with different challenges, which open up new opportunities. And they also help us working with NASA because it is such a broad base of customers that it actually gives us some leverage now and then with NASA. As I said, our airlock is called Bishop. Talking a little bit more about the programmatics. We had a bottleneck. It was the Japanese airlock on the station. Was underutilized until about 3 or 4 years ago. The Japanese started launching CubeSats out of it. We saw that, worked with the Japanese on 1 or 2 satellites, and then realized that we could put in a much more efficient deployer out of the airlock, the Japanese airlock, and that's when we started seeing incredible growth in our CubeSat business. As we did that, we actually sort of reached the capacity of the Japanese airlock, and so we came up with what we called a chess piece, Bishop, about our own airlock to see if we could get more cycles through the Japanese airlock. But as we looked at it, it really became a very viable idea on its own. We are already cutting metal. It's being part of it's already shipped from Huntsville to Turin, Italy, where a good part of it is being built by Thales Alenia. And it will get launched, currently manifested on SpaceX 19, which is in late 2019. And that will give us the ability to launch larger satellites. For the research side, it will provide an easy way to expose materials, try various in-space manufacturing items in the vacuum of space. And actually, when it's attached to the ISS, it can even act as a microgravity thermal vac chamber. So if you need to take, for those of you who are more on the tech demo side, take something up to technology readiness level 9, it'll be a great facility for that. Then, as I said, the next sort of logical conclusion to this is our own space stations. We've been looking at over the past year or so repurposing upper stages. We've worked very closely with ULA and Maxar, which is MDA and Loral all combined together as one company. And so what you're looking at here in the upper right is a repurposed Centaur, the Atlas upper stage. And we're finding that there are some very good economics about reusing structure in space. And it's been looked at really ever since Skylab. Skylab was a success. It was looked at for the shuttle tanks. What's really made it much more feasible and economically possible is advances in robotics in the past 10 years. And so we can outfit the inside of a fuel tank robotically in a fairly short amount of time at not exorbitant amount of cost. And so that gives us we feel, an advantage. But again, that's going to be part of, this is just another version of it, that's going to be part of an ecosystem. We see multiple versions of outposts. We call them Independence 1. You'll see that Independence 2 is missing. This is sort of a picture of the ISS orbit. You'll have, hopefully, a whole series of platforms in the ISS orbit to take advantage of the existing infrastructure, the SpaceX orbital and Sierra Nevada flights there, so they could go visit the station and then go visit these other platforms to drop off and pick up materials. But Independence 2 is not on there. That's because we expect that station orbit is nice, but there are lots of other orbits out there, particularly SunSync, where people will want to do research. Earth observation benefits a lot from SunSync. So we see platforms in other orbits. We may even think about co-orbiting one with the Chinese space station to take advantage of the logistics infrastructure that they'll be putting together. So that's sort of how we see the future. We will stay close to our customers. Love to talk to people who have ideas about what they want to do in space. We actually have a subsidiary called Dream Up It's a public benefit corporation that is focused on education, and happy to hook you up with them too. So I think that's it for the moment. Any questions?
Of your relationship with Russia? I understand it goes back to the 1980s. So
Yes.
You dealt with the USSR, and now you're dealing with the Russian Federation.
Right. Our CEO and founder of the company, Jeff Manberg, was the only American ever to work for Nanoracks, which, for those of you who don't know, was sort of a combination probably of Marshall, Boeing, Lockheed, and a bunch of other aerospace companies in Russia. It was the company that actually built the first rockets that took Sputnik and Gagarin to space. And it's the one that had developed the Salyut stations, which were sort of the precursors, going back to probably the early post-Skylab, but pre-ISS Russian space stations. The Mir was the last one. Jeff actually leased the Mir for a private corporation for a couple of years. Lots of politics there. But that's given us a great insight on how to think about running your own station. Right now, we talk with Russia on occasion. We also work through NASA. Things come and go there. But we're always looking for opportunities.
So I think we have to go to the next talk, but we will have a panel discussion with collector questions, and we are also getting many questions on the live stream, so we will address those on the panel. Thank you very much again, and
Yeah.
we are looking forward to independences.